Australia's a huge island continent with a relatively small spread out population. But that hasn't dented the nation's scientific ambitions.
We're 0.3% of the world's population. We're 13th in the world in the size of our economy. But we've got great big ambitions. So it's like we've got champagne ambitions with a beer budget.
For the nation's scientific community, that means finding inventive ways of sharing precious resources.
Microscopy Australia allows researchers to generate knowledge and evidence to turn their ideas into impact. We do this through a national network of facilities that are available to all. And what that allows researchers to do is really address some of society's largest challenges.
More than 4,000 researchers each year benefit from this national network of world-class facilities, and the expert staff needed to unlock their full potential.
We do this because then not every single university has to invest in these really sensitive and quite costly instruments and the experts that work alongside the researchers.
From gene therapies to cancer treatments, the future of medicine increasingly relies on precise genetic tools. Biologist Gavin Knott is using Microscopy Australia to make those tools safer.
In biology, the atoms, they're so small. We need this electron microscope to see the biology in action, to understand what's broken, so that we can then go in and fix it.
Gavin Knott's team is also using AI to design new molecules that can control gene editing systems. The challenge is ensuring those designs work outside the computer.
We used cryo-electron microscopy to prove that the molecules we dreamt in a computer actually work the way that we say they do, which is critical for translation in the clinic.
Alexander Simonov is using Microscopy Australia to tackle one of the world's most energy-intensive industries, ammonia production for fertilisers. His team is developing a new electrochemical approach that eliminates fossil fuels from the process.
This would massively decrease the carbon dioxide emissions currently associated with the ammonia production, but most importantly, it will provide sovereign safety to our local farmers who will be able to generate the fertilizers just on site and not being dependent on any global crisis that can disrupt the global supply chains.
To make the technology viable, the team needs to understand exactly what's happening at the nanoscale.
We can take an electrode, extract it from our electrolyzer device, install it into this scanning electron microscope, and understand what actually happened to it during the reaction. It is enormously powerful and extremely useful for our research.
Alexander Simonov and his research partner are currently working to commercialise their research.
Over about the last 10 years, we've looked at around 35 startups and spin-outs that have used our facilities, and within that group, they have managed to raise or done some licensing deals that equal about 4 billion Australian dollars.
Former Chief Scientist Cathy Foley says the collaborative nature of Microscopy Australia, where researchers from a wide array of disciplines are using the same facilities, can have surprising outcomes. The renowned physicist discovered this during breakthrough work on superconductors.
Coming into Microscopy Australia and being able to use some of their state-of-the-art equipment, we had created a device that had a single grain boundary, which allowed us to detect really small magnetic fields and therefore deeply buried mineral deposits that's been able to uncover billions of dollars worth of wealth for the country.
As you can see here on the bench...
From life-saving discoveries to cleaner industries, a common thread runs through it all. We need to be able to see small to solve big problems.
Lots of people, when they think of what icon would represent science, would be a microscope. People may have used them in high school, but lots of people aren't actually ever going to use the microscopes that really unlock this sort of cutting-edge research and development. Just a really incredible diverse range of vital research for Australia's future.